day, students, and welcome to another lecture on the history of India between 750 CE and 1206 CE. Today, we are going to learn about science and technology in early medieval India. Now, the history of Indian forays into science and technology has long been an area of interest for historians, with numerous detailed research works being started since the 1970s. These works have focused on the development of scientific ideas in ancient texts and the presence of different types of scientific knowledge. However, this research has been limited with regard to the time period it has given importance to. Most research starts with the ideas expressed in the Vedas and then proceeds chronologically, analyzing various texts. Much time is spent in the Gupta and immediate post Gupta period. The other area of research has been medieval technology, with a lot of research work focused on the development of Indian technology in the Mughal period. However, the early medieval period has been steadfastly ignored in a vast majority of books. This does not, however, mean that the early medieval period did not see any scientific developments. There were remarkable advances, innovations, and ideas in a variety of fields. We will therefore try to understand early medieval science by studying its various areas. In this regard, it is important to note that for the most part, early medieval science was a continuity of developments in the preceding Gupta period. The scholars of early medieval India were well aware of their predecessors, and their writings were often quoted by them. They left detailed commentaries and tried to develop their ideas further. Thus, the key to understanding early medieval science is to remember these patterns of continuity with ancient Indian science. Now, we move on to the idea of interpreting this history of science through ancient texts. It is absolutely crucial to understand the nature and organization of ancient Indian texts if they are to be used for the sources of the history of Indian science and technology. There are a large number of texts of various types, the vast majority of which fall under the Brahmanical canon. There are also some Buddhist, Jain, and Persian texts. However, for the early medieval period, the Brahmanical texts are the most important. Traditionally, the texts under consideration fall into 6 categories: the Purva Mimamsa and the Uttar Mimamsa, the Shankho and the Yoga, and the Nyaya and the Vaisheshika. All of these texts had been composed before the early medieval period, most of them having been completed by 450 CE. However, they remain extremely important for the history of science. Moreover, early medieval authors wrote extensive commentaries on these texts, which are very valuable as sources for their ideas. The Mimamsa texts are very important for the history of science. The meaning of the word Mimamsa is related to the word investigation. Most of the Mimamsas were composed by 200 BCE, but Shaborsham commented on them in the 5th century CE, Prabhakar wrote a commentary in the 7th century, and Kumarila wrote another one in the 8th century. The Mimamsas are mainly important for their discussion on the nature of sound and its propagation. The Shankho texts are very theoretical in nature, focusing on enumeration, classification, and the construction of hierarchies. There is speculation among historians that the Shankho texts have non-Brahmanical, maybe even Buddhist origins and inspiration. are very influential texts, and their ideas can be found in well known books like the Buddha Charit, the Mahabharata, the Puranas, the Dharmashastra, the Charak Samhita, and even in later Tantric texts. One of the most important Shankho texts was the Shankho Karika, which was composed between the 2nd and 4th century CE. It was commented by Gaudapada in the 6th century in his Gaudapada Bhashya. Historians, however, regard the 9th century commentary of Bachashpati Misra, the Shankhotattva Kaumudi, to be the best work of its kind. There is another related work called the Shankhosutra, dated to the 10th century CE. Indian scholars continued to be fascinated by the Shankho texts well into the medieval period. The Jog Sutra is said to have been composed by the scholar Patanjali. It has been dated between the 3rd and 5th century CE, and the related work Jog Bhashya has been dated to the 6th century CE. These in turn were commented upon by early medieval scholars like Bachashpati Mitra, who wrote the Tattva Vaisharodi, and the Bigyan Bhikkhu, who wrote the Yogavartika. These texts focus on medical treatment and give detailed information regarding the maintenance of good health. The Nyaya texts focus on philosophy, logic, and reasoning. They have an ancient history, having an origin at about the time of Gautam Buddha himself. But they came to be codified in the Nyaya Sutra around 3rd century CE. There are numerous commentaries like the 4th century Nyaya Bhashya of Vatsyayan. The 7th century also saw the composition of the Nyayavartika by Bharadwaj. This text in turn had its own commentary, the Nyayavartikata Parjatika. There was also a 9th century index called the Nyaya Shuchinibandha, and further works in the 10th century by Udayan, the Nyaya Vartita Parjatika Parishuddhi, the Nyaya Parishishta, which is regarded as a supplemental work, and the Nyaya Kusumanjali. It should be noted that the efforts were made to syncretize the Nyaya texts with those of the Vaisheshika, and the resulting Nyaya Vaisheshikas are quite common for the early medieval period. But to understand them, we must also understand the Vaisheshikas. The Vaisheshika texts are very old, with historians speculating that they predate Buddhism and may even have inspired some Jaina texts. However, there is a tremendous amount of debate regarding the dating of the main Vaisheshika text, the Vaisheshika Sutra. This text has again been eclipsed in importance by an original exposition, the Padartha Dharma Sangraha by Prashastapada, dating from the 5th century CE. This text was widely acclaimed and inspired its own commentaries, which are usually dated between the 9th and 12th centuries CE. Also, as has been remarked earlier, there existed the Nyaya Vaisheshika texts like the Nyayashad, the Shaptapadarthi, all of which are dated within the early medieval period. Apart from these texts, there were also other texts like the Niti Shastras. From this, the Chalukya text, the Manashollas of the 12th century, talked in detail about education, architecture, music, and science. These types of texts gave a lot of importance to architecture and to mensuration, which was a connected branch of knowledge. The Puranas were also important, and the Agni Puran, the Garud Puran, and the Brahma Vaivarta Puran are dated to the early medieval period. Apart from these Brahmanical texts, there were also a number of Jaina texts. Commentaries by Siddhasen, Samantabhadra, Akalanka were accompanied by the philosophical works of Haribhadra, Hemchandra, Shantishuri, etc. There was a medical text by the name of the Kolyan Karaka, and the Upangas were also composed about astronomy and mathematics. The Gonit Shar Sangraho was an extremely important part of Jaina mathematics. In this connection, it should also be noted that Arabic and Persian works are good sources for Indian science of this period. Multiple Indian books on science were studied at the Abbasid court and translated into Arabic. Moreover, the famous traveler and scholar Al-Biruni came to India, studied a range of Indian works, and wrote about them in Arabic. And apart from all of these texts, it should be noted that there existed many works regarding the development of science in India. The Bateshwar Siddhanta, the Loghu Humanasha, the Mahasiddhanta of Aryabhatta II, the Dhikoti, the Siddhanta Tilaka, the Bhashyati, and the Siddhanta Shiromani all discussed mathematics and astronomy. Now we move on to the sciences of the early medieval period. In physics, the Boishashika and the later Nyaya Boishashika texts contained a significant amount of Indian thought regarding physics of this early medieval period. Some of the chief areas of discussion are substance, motion, space, time, atomism, and the attributes of these categories. The Nyaya Boishashika texts developed a theory of causation called Arambhavada, the two chief features of which are firstly, that cause and effect are different from each other, and secondly, that there is a continuity between the two. Also, it discusses about the theory of a whole and its parts. When a whole comes into existence, it has no parts, as it is a new effect with a new beginning. But when it is destroyed, parts may form, which will have their own significance. There were also other developments, including further development of older ideas regarding elements, atom, space, and time, while commentators also wrote about motion, heat, light, etc. The senses and perception were examined, and the nature of sound was discussed, including the production, destruction, and eternality of sound. We find a detailed discussion of the nature of elements in the Nyaya Boishashika, which had their own interpretation of the traditional doctrine of five elements. These are Prithvi or earth, Apo or water, Tejas or fire, Bayu or air, and finally Akash. The earth was thought to be both eternal in the form of atoms and substantial in the form of things like the body, the olfactory sense organs, and all material things like stones, plants, etc. Earth also had its own distinctive properties like odor, touch, etc. Water was thought to be both eternal and non-eternal. Water was contained in the body, in the sense organs of taste, and objects like river, ocean, and even the moon. Water too had its own distinct properties. Fire too was thought to be both eternal and non-eternal. It influenced the visual sense organs and was present in objects like earthly and heavenly fire, like wood fire, lightning, the sun, the stomach fire, that is the digestive power of the body, and the mineral fire like gold and other elements. Air influenced the sense of touch. It had its own distinctive properties like motion and allowed breathing to happen in the body. Finally, Akash was non material and all pervading. It influenced the sense of hearing. We also need to look into the theory of atomism. Atoms were thought to produce matter of visible magnitude. They were thought to be in eternal motion and could combine with atoms of the same substance. Atomistic thought in the Nyaya Vaisheshika was remarkable for its strict adherence to principles of causality. Two atoms combining produced a dyad. Thus, the atom is the material cause for a dyad. Three dyads together form a triad, which is the minimum visible object. It was also theorized that there was an unseen force which made atoms combine. Thus, this force was thought to be the efficient cause of the material world. Another science was astronomy. Astronomy flourished in this period. Bateshwar, Manjulacharya, Aryabhatta II, Sripati, and Shatananda are especially worthy of remark. Bateshwar was a follower of Aryabhatta and wrote criticisms of Brahmagupta's system. Manjulacharya made important contributions regarding the system of equinoxes. Aryabhatta II did not have the genius of the original Aryabhatta, but he was a compiler of astronomical texts. Another notable astronomer was Bhaskar II. His Siddhanta Shiromani surpassed most contemporary works on the subject. He discussed the true motion of the planets, eclipses, planetary conjunctions, as well as theoretical problems related to astronomy. There was also detailed discussion of the types of instruments needed for astronomy. He wrote commentaries on his own works and another text called the Quran Kutuhala on planetary motion. Mathematics also flourished due to the contribution of several experts. Mahabircharya was a Jaina mathematician of the 9th century. He studied mathematics for its own sake, and his treatise was not connected to astronomy, unlike many Brahman works, even though he was knowledgeable about them. His Gonit Shar Sangraha contained detailed work about fractions, square and cube roots, quadratic and indeterminate equations, mensuration, and other mathematical theories. Aryabhatta II was also a mathematician, even though he was also an expert on astronomy. He contributed in the field of indeterminate equations and prescribed a more efficient method of solving them. Bhaskar II was considered the culmination of early medieval mathematics because of his peerless originality and innovation. He did unrivaled work in arithmetic, algebra, and geometry. It is considered that he anticipated modern algebra in his own works. His cyclic method of solving the Pelian equations have received universal acclaim even in modern times. Some of his work anticipated the invention of modern calculus. Now we come to the development of technology. The chief development was agricultural technology, and this was a key feature of this period. As historian Ranabir Chakraborty has demonstrated through a study of land grants, it can be concluded that the early medieval period saw a rapid expansion of the agricultural system. This was accompanied by increasing focus on the techniques of agriculture, resulting in the composition of long manuals, which addressed issues like collection, preservation, and sowing of seeds, leveling the field, harvesting, grain processing, proper storage, etc. Thus, the development of agricultural technology is an important area to focus on. It is known that there were as many as 60 varieties of paddy in eastern India, and even arid places like Rajasthan could boast of two crops a year. This was also the period when non cereal cash crops came to be cultivated. There was cotton, which was the basis for India's formidable and flourishing textile industry. Associated with cotton was the Indian cotton gin, which was in use as early as the 6th century. It consisted of two parallel rollers which were rotated by the palm, and they helped to separate the cotton seed from the fiber. Later, this would include gearing and the crank handle. Another Indian invention was the scotch bow or cotton carder's bow, which loosened up the cotton fiber so it could be spun into yarn. Towards the end of the early medieval period, India also developed the spinning wheel, which greatly assisted in the textile industry. The other important crop was sugarcane, the best variety of which was grown in North Bengal and which stimulated the invention of machines for extracting its sweet juice. This in turn stimulated the sugar making industry in places like Malwa and Rajasthan, and this sugar was exported abroad through the ports of Gujarat. The other important cash crop was oil seeds. Oil milling proliferated in early medieval India. A 10th century text, the Joy Mongol, mentions the Toilikas or oilmen and their machinery. First was the Audra, which was used as an oil press. The other was called the Chakrika, which was like a wheel. Other sources mention the Ghanaka, from which comes the modern word Ghani. Ghanakas were often donated to temples, and their economic importance is confirmed by an inscription that threatened serious punishment to anyone who damaged a Ghanaka. The texts of the early medieval period have detailed discussion on the preparation of manure. Various substances like cow and goat dung, washings of beef and fish, barley, sesame seeds, etc., are discussed, and the processes of preparation are properly prescribed. Cow dung, of course, got a lot of importance in this discussion. The expansion and development of agriculture was directly tied to the development of irrigation. While the monsoon does immensely benefit Indian agriculture, it is not consistent or evenly distributed across the country. It has been established by historians that the Nile flood was directly tied to monsoon rains in East Africa and South Asia. A study of this data indicates that the period from the 7th to the 10th century was a time of relatively low rainfall, and this greatly changed from the 11th century onwards. Thus, historian Ranabir Chakraborty has argued that this wetter period made irrigation easier and saw the expansion of agriculture and the construction of new settlements. Expansion was naturally accompanied by an expansion in irrigation. Thus, the king Rampal constructed huge lakes and other related public works in the Varendri region of Bengal. In fact, Bengal and Bihar saw the construction of many local hydraulic works that focused on using the ample water resources of the region for the benefit of agriculture. In western India, however, particularly in arid states like Gujarat or Rajasthan, large scale irrigation was slowly becoming the norm. Reservoirs were used to irrigate freshly sown fields, for example, while local projects like tanks and wells continued to be used. Water wheels like the Araghatta now became common. Step wells were also constructed and they continued to be used in Gujarat even in the present day. The Araghatta is an older device. It received its first mention in an inscription in 532 CE. An important part of the device was the Ghoti or the device with pitchers, which was connected to a rotating wheel with spokes. Step wells like Vapis and Araghattas were very common in arid Rajasthan and have received multiple mentions in texts and inscriptions. In peninsular India, especially in the rain shadow area of the Western Ghats, irrigation was essential. The local rulers built bunds to trap runoff water and constructed numerous tanks. Sluices were used to regulate inflow and outflow of water from a tank, and boats were used to keep them dredged. Thus, we can see that there was considerable development of science and technology in the early medieval period. While some scientific developments may not have been up to the mark of the early historical period, they were still quite considerable in extent and continued the trends of earlier times. While the majority of technological development was connected to agriculture, this was compatible with the dominant trend of the period, which was, after all, the expansion of agriculture and creation of new settlements. Thus, science and technology of the early medieval period is an essential part of the history of this time.